So in the last video we learned how to design the custom schematic component in EasyEDA from scratch. So in this video we will see that how can we create the footprint of this component from scratch. Normally the information of the footprint of any IC is given in its datasheet. So here we have the TPS 62933's datasheet. We will see if we can find any information regarding the footprint of this IC. So if you just see the last or second last page of the datasheet of this TPS 62933, we can see that there is some information about the PCB footprint of this IC. Since we know that this IC contains 1, 2, 3, 4, 5, 6, 7, 8 pins, so the footprint of this IC will also contain the 8 pins, right? So in the EasyEDA we will go to File, New and Footprint, and we can see a new footprint window in the EasyEDA when we go to File, New and Footprint, right? So first of all we have to create 8 pads for the 8 pins of the IC. For that we'll go to this footprint tools, and we will select the pad, right? And we will place this pad anywhere in the PCB layout, right? Now we'll go into the properties of this pad and change the layer to top layer, and we will make its shape to rectangle, and we will see about the height and width of the pad later. There won't be any hole, so we'll just update it. Now we can see that we have a pad that has the dimensions of 1.524 mm and 1.524 mm, right? So as we can see in the datasheet that we need the pad of the dimensions 0.67 and 0.3 mm, right? So we will change its dimensions as 0.67 and 0.3, right? Now we need 8 of them, right? We need 8 of the pads. So this one will be the first, and we can select it. We can press Ctrl C and then Ctrl V. We can change its number from 1 to 2. Alright. Now the one thing which we have to make sure about is the distance between two consecutive pads is supposed to be 0.5 mm, right? So for measuring the distance between any two pads, we have this dimension tool in EasyEDA. We'll just select that and measure the distance. Here it says that the distance is 0.6 mm, right? So this is the 0.5 mm distance. So we have to shift the pad right here, right? Now the distance between these two pads is 0.5 mm almost, right? So we can go for it. We will just copy this pad and paste it right here. We will again paste the pad here. Okay, this will be the 1, this will be the 2, this will be 3, and this pad will be 4. Now the same number of pads are required on the other side of the IC as well, right? These are only 4 pads right here. So for that, we need to know the horizontal distance between the pads, right? It is 1.48 mm here. So we need to make sure that the pads are horizontally separated by 1.48 mm distance. For that, let's use the distance calculator, and the distance is supposed to be 1.48 mm. Maybe if we lower the grid size to 0.01, 0.01, 0.01. Right? Now we need the distance of the horizontal distance of how many mm? 1.48 mm. So let's make sure that the distance is 1.48. This is the 1.48 mm distance. Right? Now we will just copy this pad and paste it right here. Exactly opposite. This will be the position of the 5th pad. We will copy again and paste the pad right here. We need to make sure that yes, this is exactly its position. We will again copy the pad and we'll place it right here. Okay, so this one will be the last pad, which will be the 8th pin of the TPS 62933 IC right here. We have placed the 8 pads. We will rename this pad as pin number 5, this one as pin number 6, this one as pin number 7, and the last pin will be the pin number 8. Okay, so this is the footprint is not yet complete. This is the major outline of the pad, that will be major outline of the footprint that is required to be created, right? So now we have to make the silk screen of the IC as well, for the indication of the body of the IC, right? So we'll go to the silk screen in the layers and objects, and we will select the rectangle right here, and we will draw a simple silk screen here. Right? Now we will change the width of the cell screen to, let's suppose, 0.2. .1. Yeah, this width is fine. This width is like more suitable because the IC is very small. So now for the indication of first pin of the IC, we have to draw a simple circle, and we'll change the width of the circle as well. 0.05. Yeah, that's more like it. This circle will be the indication of pin 1 of the TPS 62933 regulator. So our footprint is now almost complete. Alright, we have pin 1, 2, 3, 4, 5, 6, 7, 8. Our schematic component also has pin 1, 2, 3, 4, 5, 6, 7 and 8, right? So let's save this footprint and see if it works or not, right? So we will save the footprint right here. Okay, the error that it is giving is that this is supposed to be placed in the origin, right? Now this is the origin, so we have placed it in the origin, right? So now we have placed it in the you can see the origin. So let's see if it works or not. Yeah, it works. So it gives the option to save this as a footprint. We will rename it as TPS 62933 custom made, right? And we will save it. Okay, so it says that it is saved. Now if we want to assign our current footprint to this IC, right, we will select this IC and we will go into the footprint tab, and let's search our footprint that we just created, TPS 62933. We have this one and this one. Okay, let's see if it is available in the library. Select this, go to the footprint, search the TPS 62933. Yeah, we have the footprint that is custom made. We just saved this footprint and it is available in the library. So we will assign this footprint to our custom schematic component. You can see it has automatically created the virtual connection of pin 1 with pin 1, pin 2 with pin 2, pin 3 with pin 3. If the IC had like 16 pins instead of 8 and the footprint had only 8 pads, then we would have seen errors right here, right? This gives the information of component pin information. This is our component. It is giving the information of the pins of the component, right? Like the components has pin number 1 to pin number 8, and this here gives the information of the footprint pad, the information of the footprint, right? It says that the pad numbers are from pin 1 to pin 8. So we are even in both cases, right? Like the custom component also contains 8 pins, and the our custom created footprint also has 8 pins. So there won't be we won't see any errors right here. So we will update the footprint and cancel it. And now what we need to do is remove the already available schematic component, and we have to replace it with our own created schematic component, right? So we will remove this IC and we'll place our own IC right here. And we will connect it right here. We will save the schematic. Yeah. So in this video, we successfully created a custom footprint in EasyEDA from scratch, and we assigned that footprint to our custom schematic component.